Good morning, dear students. We were discussing the chapter The Thermal Properties of Matter. In the last class, we have seen the distinction between heat and temperature and the different temperature scales like Fahrenheit, then Kelvin, and also degrees Celsius, and how to convert from one scale to another scale. So these things we discussed. Now today we are moving to another topic, that is thermal expansion. Okay, thermal expansion. So you all are familiar with the jam bottles, isn't it? So you know the jam bottle has a metallic lid and it is very tightly fixed. So for opening that lid, we may place it in hot water, or we will show it to a little flame or something like that. That means we will apply some amount of heat to that metallic lid so that it is very easy to open. Why this is so? Have you ever thought of that? As when you apply hot water or when you place it in a flame, it would allow the metallic cover to expand. Okay, thereby loosening it to unscrew easily. So when heat is supplied to a material, its dimensions like length, area and volume can be changed due to change in its temperature. Understood? So this phenomenon of change in the dimensions of an object due to heat supplied is known as thermal expansion. So in the word itself, you can understand thermal means because of temperature. Okay. Then expansion. Clear? So we are applying certain temperature like heat, thermal in the sense heat. Okay. Then after applying this heat, it will change the dimensions. Dimensions can be length, then area and volume. Understood? So we can define thermal expansion as the phenomenon of change in dimensions of an object due to heat supplied. Okay, due to heat supplied. Understood? So this is called thermal expansion. Now there are three types of thermal expansion. Okay, the three types of thermal expansion are, thermal expansion is of three types. Which are they? Yes, the first one is linear expansion. Linear expansion. Now the second one is, this is the first one. Second one is area expansion, or you can call it as superficial expansion. Area or superficial expansion. And the third one is volume expansion, or you can call it as cubical expansion. Cubical expansion. Clear for you? So thermal expansion can be lengthwise, that is linear. Okay. Then area wise, that is area expansion or superficial expansion. And the third, volume wise, that is cubical expansion. So there are three types of thermal expansion. Understood? So we will discuss each one in detail. First we will move to linear expansion. Linear expansion. Okay. So as I told, the expansion in the length of a body due to the increase in its temperature. Understood? The expansion in the Linear means lengthwise. So the expansion in the length of a body due to the increase in temperature. Okay, so it is known as linear expansion. For example, if you are considering a road like this, clear. So starting, its length was L1. This was the original length. At temperature, let it be T1. Understood? And when you apply temperature or when you increase the temperature, let the temperature change from T1 to T2. Okay, temperature changed to T2. At that time what happened? Yes, there is increase in the length. So this length L1 changed to, you consider it as L2. Okay, length increased, total length is taken as L2. So this is the increased length L2. So when you check these two, you can see there is this much increase, isn't it? There is a change in the length or increase in the length. So this change you can call it as delta L. Delta means what? Change. So change in the length is actually, how will you find it? Delta L is L2 minus L1. That is the final length minus the initial length. Clear? So to find the fractional change in its length, how will you write? Fractional change in its length means the change in length with respect to the original length. Okay? Change in length with respect to original length. That is equal to delta L, as I told, it is L2 minus L1. So L2 minus L1 divided by L1. L2 minus L1 divided by L1. Understood? And you know, this particular change in the length or the fractional change in the length is always proportional to what? As increase in the temperature. Isn't it? That is change in the temperature. That means you can write this delta L by L1 is proportional to what? Is proportional to the temperature change. That is delta T. Clear? Delta T means what? Delta T is T2 minus T1. So always it is proportional because as the temperature change increases, this change in the length or the difference also increases. Clear for you? So you can write it as like this: L2 minus L1 by L1 is proportional to what? As T2 minus T1. Clear? L2 minus L1 by L1, that is a fractional change in the length, is proportional to T2 minus T1. Clear? This proportionality sign can be changed by multiplying it with a constant. That is the constant called as alpha. Okay, don't get confused. This is alpha. This is proportionality symbol. So alpha into T2 minus T1, or you can write it as delta L by L1 is equal to alpha into delta T. Clear? Or what is delta L? Delta L is alpha L1 delta T. Clear? So this alpha is known as, alpha is a constant here, and it is the coefficient of linear expansion. Coefficient of linear expansion. Clear? That is the alpha. Okay. So it is actually a characteristic of the material of the rod. Normally, metal expands more and hence relatively high values of alpha. Clear? So from this expression, this alpha can also be written as how? Alpha is equal to, how can you write? Delta L divided by L1 into delta T. Isn't it? Delta L divided by L1 into delta T. Or in words you can write, it is the increase in length. Increase in length divided by L1 is actually the original length, isn't it? Original length into rise in temperature. Clear? So how can you define this alpha? How can you define this coefficient of linear expansion? As it is the increase in length per unit original length per degree rise in temperature. Understood? Increase in length per unit original length per degree rise in temperature. So it's unit because this is length. So only unit comes for temperature, and you can write it as degrees Celsius raised to -1 or Kelvin raised to -1. Understood? So these are the units for coefficient of linear expansion. Clear for you? So we are discussing with thermal expansion, that is the phenomenon of change in the dimensions of an object when heat is supplied. Thermal expansion, 3 types: linear, then area and volume. Linear means lengthwise expansion. So the expansion in the length of a body due to increase in temperature. We are considering a rod having a length, then when you are applying temperature or when you are applying heat to that body, it expands and its length increases. So there is a change in the length and there is a change in the temperature. And when you can say that this change in length is actually proportional to the change in temperature. As the temperature increases, the length also increases. So that proportionality symbol can be changed by a constant known as coefficient of linear expansion, and here for coefficient of linear expansion you have the expression that is alpha is equal to delta L by L1 delta T. So this can be defined as the increase in length per unit original length per unit degree rise in temperature. Okay, and the units are degrees Celsius raised to -1 or Kelvin raised to -1. Clear for you? So this is all about linear expansion. Now we will move to the second type, that is area expansion. Okay. So the second one is area expansion. So instead of length we are specifying area here. So how can you define this? The expansion in the area due to increase in its temperature. Okay, expansion in the area due to increase in its temperature. It is known as what? Area expansion. Clear? So suppose if you are considering a plate like this. This is a plate. Okay, so it is having an area A1. Clear? Now when you supply heat to it, or when you are heating this particular plate, it will expand like this. Lengthwise or area wise it will expand. Okay, so the final area you can call it as A2. What is the change in area? A2 minus A1, you can call it as delta A. So this portion, this is actually the change delta A. Clear? So now there is a temperature and the starting it is taken as T1. Finally A2 temperature is T2. So the change in temperature is T2 minus T1, which is delta T. We know that. Now here also same as before, you can write like delta A, that is a fractional change in area, okay, to the original area is what? As it is proportional to, how can you write the change in temperature delta T? Clear? That is delta A is equal to the constant of proportionality. You can write it as beta or you can write it as alpha A. Clear? So I am using here beta and delta T into A1 also. Clear? Beta then A1 delta T. So this beta is actually the coefficient of area expansion. So beta is equal to delta A by A1 into delta T. Clear? How can you define? Yes, it is the coefficient of area expansion of a metal sheet or a metal plate. You can define it as the increase in the surface area per unit original surface area per degree rise in temperature. So its unit is again degree Celsius raised to -1 or Kelvin raised to -1. Clear for you? So this is the area expansion. Okay. Now we will move to the third one, that is volume expansion. So the expansion in the volume of an object due to increase in temperature. The expansion in the volume of an object with increase in temperature. That is known as what? Volume expansion. Clear? That is, for example, if you are considering a cube like this. This is a cube. Okay. Okay, this is a cube. Now when you apply heat to it, it will expand volume wise. So let its volume be like this. Okay, like this it increased. Clear for you? Okay, so like this its volume increased. So initially its volume was V1 and finally it changed to V2. So the change in volume is V2 minus V1, which is delta V. Now the temperature, as you know, first it was T1 and then it becomes T2. So change in temperature is T2 minus T1 is delta T. Now similarly, similar to the last expression, you can write it as the fractional change in volume, that is delta V by V1. Delta V by V1, you can write it as what? V2 minus V1 by V1, isn't it? And it is actually proportional to the change in temperature. So that is delta V by V1 is proportional to delta T, and delta V is proportional to V1 delta T. Proportionality sign can be changed with gamma. So V1 into delta T. Clear? So this gamma is actually the coefficient of volume expansion. Gamma is known as the coefficient of volume expansion. Clear? Coefficient of oleum expansion or cubical expansion. So again you can define this gamma like this, delta V by V1 delta T. Look here, how can you define? As it is the change in oleum, okay, or increase in oleum per unit original oleum per degree rise in temperature. Understood? The coefficient of oleum expansion is actually the change in oleum or the increase in oleum per unit original oleum per unit degree rise in temperature. So this is also a characteristic of the material of object, okay, but not strictly a constant. The coefficient of oleum expansion depends generally on temperature, and its value first increases in temperature and then becomes constant at a higher temperature. Okay, like this. If you are drawing a graph for temperature and this value, okay, you can see that first its value increases like this and then it remains as a constant. Understood? So this is a graph between this coefficient of oleum expansion and temperature. Clear for you? So these are the three types of thermal expansion. Now there is a relation among the coefficients of expansion. That is, the ratio is given as alpha is to beta is to gamma. Alpha is to beta is to gamma is equal to 1 is to 2 is to 3. Okay, 1 is to 2 is to 3. That's the relation, or you can write beta is equal to 2 alpha. You can prove this one. Okay, beta equal to 2 alpha, or gamma equal to, you can write it as 3 alpha. Okay, beta equal to 2 alpha or gamma equal to 3 alpha. So these are the relations between alpha, beta and gamma. Clear? So that's all about the thermal expansion and its related types. Clear for you? Linear, then area and oleum. Now the relation is alpha is to beta is to gamma is 1 is to 2 is to 3, or beta equal to 2 alpha, or you can write gamma equal to 3 alpha. Clear?